what really happened in the distant past of our planet? Imagine an Earth very different from the one we know today. A planet covered in lush vegetation, where there were no changing seasons, and the climate was stable, mild and humid, like an eternal spring. This scenario, reconstructed through various paleoclimatic theories and geological observations, serves as the backdrop for the hypothesis of ancient gigantism. Some scientists studying the growth rings of fossilized trees and the distribution of organic sediments suggest that during the Paleozoic and Mesozoic eras, the climate was surprisingly uniform across many regions of the Earth. In particular, according to studies in paleobotany, such as those reported by Edith Taylor, Thomas Taylor, and Michael Krings in the book Paleobotany, The Biology and Evolution of Fossil Plants. Vast tropical forests once extended into regions that today have temperate or even cold climates. One of the most fascinating hypotheses is the presence of an atmospheric canopy, a sort of double atmosphere or natural dome of water vapor. In ancient times, this vapor canopy may have filtered out harmful solar radiation and retained heat uniformly. This model, supported by some independent researchers and occasionally discussed in alternative scientific circles, would explain a climate without significant temperature fluctuations. Such a vapor cover would have created a natural but beneficial greenhouse effect, similar to a global closed biosphere. In this stable environment, temperature would remain constant throughout the year. Humidity would always be high. These ideal living conditions could have favored longevity and continuous growth in living organisms. In such a perfect ecosystem, plants and animals could have grown for long periods, reaching sizes unimaginable today. It's no coincidence that dinosaurs, colossal beings per excellence, lived during a time when such climate conditions seemed to prevail. According to certain ancient traditions and mythologies, even humans lived longer and had different physical forms. Biblical genealogies speak of patriarchs who lived for hundreds of years, like Methuselah and Noah. Similar legends are found in Sumerian, Vedic, and Chinese texts. We are not just talking about myth. The idea of a climatic golden age echoes in modern geological studies, such as those on Milankovitch cycles. These show how variations in Earth's axial tilt and orbital shape have deeply influenced our planet's climate over millennia. Before a major rupture, possibly caused by a cosmic impact, a magnetic pole reversal, or orbital changes, the Earth may truly have been a giant ecosystem capable of hosting equally giant creatures. One of the most intriguing hypotheses about ancient Earth involves the structure of the atmosphere itself. Some scholars and independent researchers suggest that, in a remote epoch, our planet may have been surrounded by a second atmospheric dome, a kind of protective layer composed mainly of water vapor or light hydrocarbons, suspended at high altitudes. This firmament, as it has been called in many ancient traditions, may have acted as a natural filter for solar rays, reducing exposure to UV radiation and maintaining a stable, mild, and humid global temperature without the seasonal fluctuations we are familiar with today. Such a condition would have made Earth resemble a planetary greenhouse, a perfect environment for the development of giant and long-lived life forms. In this context, a slowed metabolism and the absence of thermal shocks may have contributed to the continuous growth of organisms. Some research in the fields of geophysics and paleoclimatic climatology, such as the work of Joseph Daniel Dwyer and the simulated models by Robert Strom, supports the idea that Earth's atmosphere has undergone drastic structural changes over the ages, possibly due to cosmic events or planetary cataclysms. This ideal phase in which the Earth was protected and fertile could help explain not only the presence of giant flora and fauna, but also the greater longevity of many species, including humans. Although the idea of a second atmospheric dome remains partially speculative, there are serious paleoclimatic and geophysical studies that explore the possibility that Earth's atmosphere was once radically different. One of the main areas of research focuses on the chemical composition of the atmosphere during the Paleozoic and Mesozoic eras. According to studies by Robert Strom, Professor Emeritus of Planetary Sciences at the University of Arizona, atmospheric density in the past may have been much higher than it is today. This would have contributed to a natural greenhouse effect, maintaining high and stable temperatures across the planet. At the same time, geophysicist Joseph Daniel Dwyer, known for his research on the upper atmosphere and electrical discharges, has pointed out that Earth's atmosphere is susceptible to sudden structural changes when exposed to high-energy events, such as meteor impacts or magnetic pole reversals, which may have permanently disrupted the natural dome that once protected primordial Earth. Another interesting clue comes from studies of fossilized air bubbles found in ancient sediments and resins, such as amber. These sometimes show higher oxygen levels and atmospheric pressure compared to today's environment. Such data supports the hypothesis that the Earth's environment was once richer in oxygen and protected by a thicker gaseous envelope. Even in the fields of archaeoastronomy and comparative mythology, scholars like David Talbot and Anthony Parrott have proposed that the ancient perception of the sky, described as a fixed, luminous dome, may have had a physical basis connected to the structure of Earth's pre-catastrophic atmosphere. Finally, some experimental climatology simulations suggest that, in the presence of higher global humidity and the absence of high-altitude winds, a stable thermal balance could have been maintained without seasons or extreme weather conditions. Throughout Earth's geological history, it is believed that our planet has undergone many atmospheric phases, very different from what we know today. A particularly fascinating theory, supported by paleoclimatology and geochemical studies, proposes the existence of a second atmosphere, an era with higher oxygen concentration and density. As always, we invite you to subscribe to our channel. It's a small gesture that helps us immensely and ensures you don't miss the upcoming updates on topics that are hard to find elsewhere. During the Carboniferous period, around 300 million years ago, atmospheric oxygen levels may have reached up to 35% compared to the current 21%. This condition, documented by isotopic analyses of ancient air bubbles trapped in amber or in the inclusions of crystals, might have favored the development of organisms of colossal size. In such an environment, the higher atmospheric pressure would have increased air density, improving the absorption of oxygen through the body surfaces. This was particularly relevant for insects, reptiles, and amphibians. Giant insects such as the Meganeura, a dragonfly with a wingspan of over 70 centimeters, or the Arthropleura, a millipede over 2 meters long, are just a few concrete examples from this era. Some scientists, such as biologist Robert Berner from Yale University, author of the geocarb sulf model, have explored the impact of oxygen and CO2 over millions of years, showing how these atmospheric variations influence the evolution of life. Additionally, there is the hypothesis of greater natural protection against solar radiation, possibly due to a thicker water vapor layer or a more extensive magnetic field, which could have shielded the Earth's surface. This would have promoted not only a longer lifespan for organisms, but also continuous growth, free from the interruptions caused today by environmental or seasonal stress. In this scenario, Earth appeared like a massive planetary greenhouse, where life had the ideal conditions to thrive in size and duration, before large disruptions, climatic, cosmic, or geological, altered its course forever. Recent studies, such as those conducted by Alexander Kaiser from the University of Ulm, have highlighted a direct correlation between increased oxygen levels and the larger body sizes of insects. Experiments carried out in controlled environments with high oxygen levels have shown that modern insects grow significantly larger in hyperoxygenated conditions. An oxygen-rich atmosphere, while favoring a more efficient metabolism and accentuated growth, also led to a higher flammability of the environment. The presence of geological layers rich in fossilized carbon and remnants of fires suggests that vast natural fires were frequent. These factors, along with climate changes and the appearance of more agile and specialized predators, might have contributed to the decline of gigantism in the animal kingdom. One of the most fascinating and mysterious theories regarding ancient gigantism is the possibility that Earth had a more vertical axis in ancient times. If the Earth's axial tilt had been minimal or even absent, sunlight would have a stable climate for eternal spring. This scenario could have created ideal conditions for life, with mild temperatures in every season and no dramatic climate alternations, much like an eternal spring. In a world without seasons, plants and animals would have had continuous and stable access to resources, favoring incessant growth. Tropical and subtropical flora could have thrived in places that are now colder, and living organisms would have had the chance to grow without the limitations of freezing periods or excessive heat. Some scientists suggest that the Earth's axis may have been tilted as a result of catastrophic events, such as cosmic impacts or large tectonic shifts. These changes would have altered the distribution of sunlight and led to the formation of seasons, an event that would have had a devastating impact on the global climate and the ecosystems that existed. The arrival of the seasons, with their cycles of extreme heat and intense cold, would have created much less favorable conditions for the giant growth of plants and animals. Some researchers have studied the variation of the Earth's axial tilt over the millennia. Geological evidence, such as sedimentary layers and data obtained from core samples, shows signs of major cataclysms that may have caused the axis shift, drastically changing the climate and environments where life thrived. Additionally, climate models simulate how axial tilt can influence ecosystem behavior and species adaptation. Ancient biblical traditions tell of legendary figures who lived for hundreds of years, such as Methuselah, who according to the Bible lived for over 900 years. These stories are often interpreted symbolically or mythologically, but it's interesting to explore whether there could be scientific reasons to justify the existence of extraordinary longevity in ancient Earth, especially in a time characterized by an environment very different from the one we know today. One of the key factors that might explain the hypothesis of longer lifespans is the stable climate and favorable environmental conditions. In an era with constant temperatures, without extreme seasonal fluctuations, life on Earth could have thrived in a healthier way, with less stress. The reduced exposure to environmental stress factors, such as direct solar radiation during hot seasons or extreme cold periods, would have slowed cellular deterioration, contributing to a slower aging process. Ancient Earth, with its dense and protective atmosphere, could have reduced exposure to harmful cosmic radiation, which would have had a positive impact on the health and aging of living beings. Recent studies have shown that greater protection from radiation could have slowed cellular aging processes, allowing for longer lives. If life on Earth were subject to fewer genetic mutations due to radiation, the chances of living a long life could have been significantly increased. Another factor that might have contributed to the longevity of ancient living beings is the quality of nutrition. In a world with lush vegetation and a stable environment, food resources would have been abundant and more easily accessible. A constant and healthy diet, free from deficiencies, could have slowed the aging process. Along with oxygen-rich air and an environment free from many of the threats we encounter today, it would have been much easier to live a long life. Recent scientific studies have explored how the combination of these factors, stable climate, high oxygen levels, and reduced exposure to radiation, could influence lifespan. Research in biology and genetics has shown that organisms living in less stressful environments with access to abundant nutrition tend to live longer. Longevity in some modern species, such as Galapagos, tortoises, or whales, has been attributed to a mix of favorable ecological factors in biology that allows for slow aging. According to some theories, before major cataclysmic events like the biblical flood, Earth enjoyed more stable conditions favorable to prolonged life. An even and mild climate, an atmosphere rich in humidity, greater atmospheric protection from a possible double atmosphere or water vapor dome, and reduced exposure to ultraviolet rays. After the flood, interpreted also as a planetary cataclysm that may have changed the tilt of the Earth's axis, these ideal conditions would have vanished. The onset of seasonal alternation, increased thermal shocks, and direct exposure to solar radiation would have led to a gradual decrease in human longevity, as also reported in the biblical texts after the flood. Many theories converge on the hypothesis that a cataclysmic event of planetary scale marked the end of the gigantism era on Earth. Among the most discussed causes are asteroid impacts, intense volcanic activity, and the disintegration of the so-called atmospheric vault, a double layer that may have protected the planet in ancient times. These phenomena would have triggered a series of consequences, including the tilt of the Earth's axis, a drastic global climate change, and the progressive reduction of atmospheric oxygen concentration. In these new conditions, gigantism, both in the animal kingdom and among humans, was no longer sustainable. Natural selection would have favored smaller, more resilient life forms, capable of adapting to a much different environment. However, several sources suggest that gigantism did not completely disappear with the cataclysm, but left remnants and traces long after the pre-flood era. The case of the biblical giant Goliath, described as a warrior of enormous size, and other stories in the ancient traditions of various civilizations, seem to indicate that some giant individuals survived even after the flood, although in very small numbers. The same is true for certain animal and plant species of exceptional size, now extinct or greatly reduced. It is in this context that the unconventional but intriguing hypothesis arises. Humans and large prehistoric reptiles, commonly identified as dinosaurs, may have coexisted during the same time frame before the Great Planetary Cataclysm. Supporting this alternative view are studies and anomalous discoveries that challenge the footprints of the Paluxy River, Texas, where fossilized marks are said to show human footprints alongside those of dinosaurs. The Ica stones and rock carvings in Peru, which depict humans interacting with large reptiles similar to dinosaurs. Traditional narratives from native cultures recount the existence of terrestrial dragons or giant lizards, often interpreted as oral memories of animals that have since disappeared. The discovery of soft tissues in dinosaur fossils by paleontologist Mary Schweitzer, which raised questions about the true age of these remains. The studies of revisionist authors, such as Michael Cremo, who document the presence of humanoid footprints and tools found in geological layers considered too old for human presence. Although these hypotheses are not accepted by the dominant academic paradigm, they open a window to a broader and more integrated reinterpretation of Earth's past, where humans and giant creatures might have actually shared the same world before the cataclysm that forever changed its face. According to the biblical narrative, at the end of the flood, Noah saw a rainbow for the first time in the sky. This event is often interpreted not only as a symbol of peace and the covenant between God and humanity, but also as a sign of the radical climatic and atmospheric change that had forever transformed the Earth's face. The rainbow, in fact, cannot form without the refraction of sunlight through tiny water droplets suspended in the atmosphere. This implies that before the flood, there was no rain as we know it today. Some scholars argue that this was due to the existence, in ancient times, of a double atmosphere or water vapor canopy, a gaseous envelope that would have protected the planet from extreme radiation, maintained a uniform climate, and prevented heavy precipitation. This atmospheric balance, however, would have collapsed suddenly due to a meteorite impact, an event that triggered a global catastrophe. The hypothesis is supported by various alternative research, such as those presented by scholars of the hydroplate theory, coordinated by Walt Brown, and models exploring the possibility of a vertical expulsion of underground waters combined with the collapse of the celestial water canopy. The canopy theory model, developed by creationist scholars such as Henry Madison Morris and John Clement Whitcomb, hypothesizes that a thick water vapor dome enveloped the primordial Earth, contributing to a uniform climate, the longevity of living beings, and protection from cosmic radiation. Although controversial in traditional academic circles, this theory has also been picked up by some independent researchers who analyze fossils, ancient ocean levels, and geological anomalies. In the field of geophysics, other scholars have proposed scenarios of global atmospheric catastrophes linked to meteorite impacts or planetary-scale volcanic events, as highlighted by works published in journals like Geology and Earth and Planetary Science Letters. These studies suggest that large impacts could have significantly altered the composition of the atmosphere, triggering a massive release of water vapor and forever changing the Earth's climate system. According to these studies, the rain that caused the Great Flood was not just meteorological, but resulted from an atmospheric collapse accompanied by enormous explosions of underground water that changed the Earth's axis, the living conditions, human longevity, and the structure of the world as we know it today. It is at the end of this cataclysm that the first rainbow manifests, a natural phenomenon that encompasses beauty, hope, and rebirth, but also a profound cosmic transformation. The sky opens, light filters in a new way, and water is still suspended in the air. Humanity has lost its original world, but it receives a new one. That arc of colors is not only a biblical symbol, but also a visual testament to an irreversible change, an era that closes and a new earth that begins. Hi, I'm John. Our journey into mystery continues. If you want to uncover more hidden truths and answers to the greatest enigmas, leave a like, subscribe, and hit the bell. Together we'll explore the unknown, and who knows what secrets we'll find.